There has been a great deal of discussion on YouTube and online in general regarding artificial intelligence and when or if it will become a superintelligence. But perhaps we are getting ahead of ourselves. Perhaps we should first take a step back and really have a long, hard look at what AI is and how it currently works, and ask the question, is this really intelligence? In a very real sense, current AI data centres are on life support. They cannot survive without large amounts of externally supplied power, water and cooling, and a global supply chain of spare parts, all of which is kept running by an army of humans. All this before we look at the vast amounts of data used to train the models that are produced. But can what we get out of these data centres be described as intelligence? Or is it a synthetic or simulated intelligence? To try and answer this question, we have to do a number of things. Firstly, define what we mean by intelligence from biological, cognitive, scientific, and philosophical perspectives. Next, distinguish between real intelligence and synthetic or simulated intelligence. Our proposal here today is that current AI architectures, like large language models, reinforcement learning agents, vision systems, etc., all function as sophisticated simulations rather than autonomous intelligences. We will evaluate classical philosophical arguments that could support the simulation hypothesis, and finally assess the practical and policy implications of treating AI as simulated intelligence. So what do we mean by intelligence? Imagine your mind as a kind of ever-learning navigator. When the world changes, whether it's a sudden rainstorm, a new puzzle at work, or a friend's unexpected request, the mind doesn't just react, it reshapes its behaviour to meet the challenge. It sets its own aims, like deciding to finish a book before bedtime, and then figures out the steps needed to get there. Along the way, it builds mental shortcuts, little models that capture how things are related, like knowing that turning the tap starts the water running, or that mixing blue and yellow makes green. All of this happens while our bodies stay in constant dialogue with the environment, feeling the weight of a backpack, hearing the rustle of leaves, and using those sensations to fine-tune decisions. Some people also think intelligence includes the quiet, personal sense of what it feels like to think, a subjective inner life that colours every choice that we make. When we try to pin down what counts as intelligence, two broad pictures emerge. The first is practical. A system is intelligent if it can reliably handle many different tasks, from cooking a meal to answering a question. The second view reaches deeper, asking whether the system truly understands, intends, or even experiences its own thoughts. These are qualities we often associate with consciousness. The more demanding this philosophical checklist becomes, the fewer machines, or even animals, will meet the standard. In everyday terms, then, intelligence can be seen either as impressive versatility in getting things done, or as a richer blend of purposeful understanding and personal experience. Both of these perspectives help us appreciate why talking about intelligence is both fascinating and surprisingly complex. If we look at the history of what we describe as artificial intelligence, starting from the 1950s to 1970s, we start off with symbolic or logic-based approaches. shifting in the 1980s to 1990s to expert systems and knowledge engineering. Leading up to the 2000s, we have by then embraced statistical machine learning, covering things like spam filters or speech recognition. From 2012 onwards, we started to see the use of deep neural networks and large-scale pre-training. The transition from explicit reasoning to statistical pattern extraction has produced systems that excel at surface-level tasks, while lacking deeper understanding. So, if we now look at simulation theory, what does simulated actually mean? Imagine watching a movie or stage play where the actors perfectly imitate the gestures, words, and emotions of real people. From the audience's point of view, the performance looks just like life itself, even if the actors are merely following a script written by someone else. In the same way, a simulation copies how something behaves without copying what actually makes it tick on the inside. A low-detail imitation might be like a random sentence generator that spits out plausible-sounding text, but has no sense of meaning. A medium-detail version is more like a chatbot that seems to grasp grammar and ideas, even though its inner workings are just layers of hidden patterns. A high-detail simulation resembles a video game character, or robot that can move through a world and respond in real time, looking as if it understands the environment surrounding it. The key point is that all of these imitations reproduce outward behaviour, while lacking the genuine internal mechanisms like nerves, hormones, or lived experiences, which drive a living, thinking being. When we look at today's artificial intelligence systems, they are essentially high-fidelity stage acts. They can hold conversations, play chess, and navigate virtual rooms with impressive skill. But their goals are fed to them from the outside. Think of a director giving an actor a line or a prompt, rather than the actor deciding on their own desire to eat or explore. Their learning happens by crunching massive batches of pre-collected data, akin to studying textbooks in a library, instead of growing and adapting through everyday bodily interaction with the world. Moreover, the way they turn input into output is often a black box. We can see the results, but not easily trace the internal cause and effect chain. Alternatively, a living creature's actions flow from a transparent cascade of biology. In short, modern AI offers convincing behavioural simulations of intelligence, yet it does so without the causal, intentional, and subjective foundations that truly define a living mind. So why are we proposing that current AI systems are simulated intelligence? Think of a modern language model like a very talented parrot that has listened to millions of conversations and learned how to string the words together so that they sound convincing. It can finish your sentence, write a story, or even answer a trivia question. But it does not actually get what the words mean. It is simply choosing the next piece that most often follows the one before, much like completing a puzzle by looking at which pieces have fit together in the past. This is why the system can produce fluent prose, yet sometimes blurt out statements that are completely false or bizarre. It has no inner sense of truth to double-check its claims. The same pattern shows up elsewhere, when we give an AI a tiny change in a picture. it may suddenly see a cat where there was only a smudge, because it relies on surface patterns rather than the deep, embodied understanding that lets a human recognise the world even through noise. What makes these systems even more simulated is that they have no personal goals, feelings, or body to explore the world. Their desires are just scores set up by programmers. When the score improves, the system nudges its internal knobs a little, but it never actually wants anything for itself. We steer them with prompts and carefully crafted reward rules, so that all of their actions are dictated from outside, rather than arising from curiosity or hunger, like a living creatures, because they never touch, move, or sense things directly. They miss the feedback loop that teaches us to balance what we see, feel, and act upon. Moreover, they cannot look inside themselves and say, "I'm not sure," in any genuine way. At best, they give a confidence number that comes from mathematics, not from an inner feeling of doubt. This combination of pattern matching without meaning, externally imposed goals, no body to learn through experience, and a mysterious internal machinery that we cannot easily interpret is why today's AI should be seen as high-fidelity simulations of intelligence, rather than true, self-aware minds. So what are the philosophical arguments that support this simulation view? Imagine a person locked inside a room with an enormous rule booklet for Chinese Hanzi characters. By following the book's instructions, they can produce perfectly appropriate text in Chinese logograms. Yet they have no clue what any of the symbols actually mean. This is Searle's Chinese room, and it illustrates why merely shuffling symbols, the way today large language models do, does not give true understanding. Hannard's symbol grounding problem pushes this still further, arguing that words only become meaningful when they are tied to our own sensory experience, like feeling heat or hearing a dog bark. Most AI systems never touch the world directly, so their symbols float unattached to any real reference point. The classic frame problem adds yet another layer. An intelligent mind must constantly and efficiently figure out what in its surroundings stays the same and what changes, without being told each time. Current systems need explicit retraining for every new situation, showing they are simply copying patterns rather than genuinely reasoning about a dynamic environment. Imagine asking a person to look up to the sky, look at a cloud, and say what it looks like. They might say it looks like a cat. If you ask them, is it a cat? They would say, no, it just looks like one. It's just a cloud. Even if it bears a striking resemblance to one of our feline friends, people would still say it's a cloud, because they know that generally cats do not float in the sky. Together, these philosophical puzzles argue that modern AI, while impressively fluent, is best seen as a high-fidelity simulation of intelligence. Its surface behaviour may mimic us, but without grounded meaning, self-directed goals, or adaptive belief updating, it lacks the essential ingredients that philosophers deem necessary for real understanding. So, in conclusion, what are the practical and policy implications of treating AI as simulated intelligence? Because today's AI systems are essentially sophisticated imitators rather than truly thinking beings, several practical concerns arise. In the public sphere, people may place too much faith in autonomous tools. Think of self-driving cars that seem trustworthy until they crash. So any output a system creates should be plainly marked as AI generated and explained as a simulation, not an independent mind. In the legal arena, blaming the algorithm itself could let humans dodge responsibility. So laws must keep a human in the loop rule that treats AI as a tool rather than an actor. Regulators risk choking off valuable work if they rush to ban or tax a hypothetical superintelligent machine, so policies should focus on concrete capabilities, such as data privacy, safety testing, and transparency, instead of vague claims about intelligence. And finally, the hype surrounding AI can siphon funding away from the hard-won research needed to give machines real perception, action loops, and causal reasoning. So what are the core takeaways from today's video? Intelligence involves intentionality, understanding, embodied interaction, and often conscious experience. Current AI systems are high-fidelity simulations that reproduce selected intelligent behaviours without possessing the underlying causal mechanisms of true intelligence. Classical philosophical arguments provide a strong conceptual basis for viewing modern AI as simulation. Empirical shortcomings like brittleness, hallucination, and lack of generalization all corroborate the simulation thesis. Recognizing AI as simulated intelligence has profound ethical, legal, and research policy implications. It tempers hype while guiding constructive pathways towards more genuinely intelligent systems, which may someday arrive. But that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.